All right, so this is the key features of graphs, foldable. So we've already talked about domain and range, which is also a key feature. So these are all the other key features you need to know. So we're going to start with the intercepts, which I know you've heard in middle school. So we're going to start with the x-intercept. Is the point where the graph crosses the x-axis. Where is the x-axis on the graph? The bottom. So we usually refer to that as the horizontal. It's going horizontally. So go ahead and label x there so you know where it is. Something else, I got this graph on Google Images just because I liked how it had all the different features we're going over. One thing I don't like is they just put the units. Usually we also want to put time in seconds. So go ahead and add time. And then the y-axis is the vertical. And then they just put feet, but we also want to add that that's height in feet. All right, so add those to our graph. And then to color code, if you're using your highlighters, let's mark with our highlighters where the x-intercepts are. So for these, we always want to use ordered pairs for the intercepts. What ordered pairs? There's two places where this line touches the x-axis. Where are those two places? 0, 0. So you can any color you want to choose. And then what's the other?
10. I mean 10, 0, 10.
10, 0 is right here. The line doesn't touch 10, 0.
I mean 20.
Yeah, be careful. Again, I got it off Google Images, and if you want to rewrite that, that's 20 underneath. In case it's hard for you to tell, that's 20 right there. All right, and then to color code it, I'm going to highlight with my same color the word x-intercept, just so then when you're looking for it, it's easy to kind of find it because it's the same color. You may want to make a note that these are always the ordered pairs, so I'm just going to write above ordered pairs. I will mark you off if you don't use ordered pairs. So you have to make sure you're using the proper notation. And then let's write the ordered pairs. So that was 0, 0, and 20, 0. The y value will always equal 0 when y equals 0. So notice how that second number is always going to be 0. And then if you want to highlight those ordered pairs so we know where we got them. All right, the other one is the y-intercept. And it's the point where the graph crosses the y-axis. So it's going to be the opposite of the x-intercept in a sense. It's when x equals 0. So using a different color, what is the ordered pair of the y-intercept? That's when x equals 6. It's 0, 0. So it can be the same. If it's the origin, it's going to be both the y-intercept and the x-intercept, or one of the x-intercepts. So maybe if you're using a highlighter, highlight around the other highlighted point to show that it's both of those. and that's at 0, 0. And then color coordinate, highlight the word in the ordered pair. The 0, 0? Which one? Y-intercept is the point where the graph crosses y-axis when x equals 0. Any questions about the intercepts? Hopefully you remember those from previous math classes. All right, then we're going to go underneath there to the intervals. So we have increasing intervals and decreasing intervals. So to determine the intervals, of the increasing and decreasing we read the graph from left to right. And we're always going to use inequality notation, which is the same way we write the domain. So if you want to add inequality notation, or you can just write inequality. I know that's kind of long. So notation is just the way we write it. So it's always going to be with the inequalities. The furthest left point less than or equal to x less than or equal to the furthest right point. So it's the exact same setup as we would write domain, which is so we always record the x coordinates. So just like domain, we're just looking at the x values. So I'm going to use a different highlighter. And then let's first look for the increasing. So I'm going to highlight the word increasing with the color. Or if you're using a pen, you could put like a box around the word with your pen. And then I'm going to highlight, or you can use your pen to draw over the line. But where on here, if we're just looking at the x-axis between, like, for example, this first line, see how the line's going up? So that's an increasing. At what point does it stop going up on the x-axis? Right, and then at that on the x is 7. So it goes from 0 to 7 increasing. So it's we're gonna be kind of marking a lot on the graph. So you can either write it, like if you want to write it just right next to it, or you could draw a line and write it up here somewhere. But I'm just gonna write it next to it. So we would still use the brackets, and so we would show 0 less than or equal to x less than or equal to 7. So it's telling us that it's increasing from 0 to 7 seconds, because x is seconds. Where else is the roller coaster ride increasing? At which seconds? Looking at the x-axis. Like, see how it starts going down here, then right here it starts going up. What's this number on the x-axis? 10, and then it goes up to here. What's that number on the x-axis? 13. Remember, we're looking down here, go down to the x-axis, that's 13. So again, if you don't want to write on the graph, you could always like draw like an arrow up here and say from 10 less than or equal to x less than or equal to 13. Oop, you can't see mine. So that's where it's increasing again. It's going up. Is it increasing in any other places? No. So the rest is going to be where it's decreasing. It's going down in on those other lines that we haven't highlighted. So using a different color, I'm going to highlight decreasing. So between these 2 points it's going down, and then this at the very end it goes all the way down. What are the x values on this first dip, where it's decreasing right here? What are the x values? Like right here, where does it start decreasing? 7, and then where does it stop? 10, yeah, so 7 to 10. So decreasing, 7 less than or equal to x, less than or equal to 10. And then what are the x values on this last line that it's decreasing? 13 to 20. All right, now for underneath the graph, dependent, independent variable. So the dependent is always what's labeled on the y-axis. And you're looking at the words. So we're not talking about numbers. So like on the y-axis, what's labeled in words? Feet, height, and feet. So always include, so it's height, and then in feet is the units. So that's right, the height in feet of the roller coaster depends on what is written on the x-axis. Time in seconds, exactly. Because we always want to say what we're measuring in, because time can be measured in minutes, hours. So we want to make sure we write what height could be meters, it could be kilometers. Like we just want to make sure we're including the units, because that makes a big difference. So independent is always on the x side. So any time I ask for that, I expect you to write in words what's like labeled on that graph. All right, now let's go up here. So now we're going to talk about the extrema. So up here is the relative extrema. And there's the relative maximum and minimum. So a relative maximum, I'm just going to use max for maximum. If you have room to write it out, you can. It's a high point where the graph changes direction from increasing to decreasing. So we already highlighted where it was increasing and then decreasing. So see where my highlighter colors change? So it was increasing in my blue highlighter, and then when it went to pink, that's when it changed directions. Now, that's why I want you to always look at your notes and get used to the different notations, because sometimes it's hard to remember all. Like intercepts are always ordered pairs, but for the extrema, it's always the y value. So I would just get in the habit of writing y equals to remember y value only. So right here where it changes direction, I'm running out of colors to use. I'm just going to use a different color pen. So right here where it changes direction, what's the y value of that point? 13. So now we're going over to the y-axis, 13 right here. So it'd be y equals 13. And then look at where my other, so up here goes to blues increasing, pinks decreasing. So this point is also a relative maximum. So maybe draw arrows, right, relative max. And what is the y value of this other one here? 18. So y equals 13 and y equals 18. And then the opposite is a relative minimum. So that's going to be a low point. Where it changes direction from decreasing to increasing. So it's the opposite. Also, just to point out, it only changes directions. We call that the open domain. So like the endpoints aren't included in the relative maximum and minimum. Because like if we start at the endpoint, the starting point 0, 0, it's only going up. It's not changing direction. And like if we go to the endpoint, it's only going down. It's decreasing. It's not changing direction. So endpoints don't count when we're talking about the relative extrema. So it's only when you see, so like the maximums would be like a mountain peak, like I think of a mountain, like it's at the top or peak of a mountain. And then like the relative minimum would be like a valley when it like dips low. Whatever helps you see it, but I think of like a mountain. So this one would be where it's dipping low, it's going from decreasing and then it starts increasing. What's the y value there? Where is this point on the y-axis? 10. So y equals 10. If circling it is enough for you, you can do that. Or again, like if it helps you, maybe draw an arrow and say relative min off to the side. As long as you have like the general information, like again, these are your notes. As long as you have, you know, the main vocab terms, like you can label it what makes sense to you. Just make sure you're color coding in some way. All right, last section is the absolute extrema. So absolute maximum, absolute minimum. So it's including the entire graph, endpoints included. So we'll start with a relative maximum. So relative max is the highest point. So it's just the very highest point over the entire domain. So which point on the graph is the very highest point that this roller coaster, like what's the height that is the highest the roller coaster gets to? 18. So we would go over here, remember y-axis. So that highest point is y equals 18. Remember y values only for these. I know it's really busy, so if you want to mark it somewhere over here, if you just feel like it's enough to write it over here, I don't know, I might circle it again. I know there's a lot going on here. So that's absolute max. I'm about to write relative. If you don't want to put it on the graph because it's too busy, that's okay. But if it helps you. Okay, so that's the absolute max. And then the other one would be the absolute, I'm sorry, I just realized I wrote relative. Sorry about that, you guys. That should be absolute. We already talked about the relative. Absolute max. And then that other one is absolute minimum. So it's the very lowest point. So in this case, what's the very lowest height at 0? Lowest point over the entire domain, and the lowest point is y equals 0, which we have both the starting point and the end point are at y equals 0. All right, when you are ready, I'll keep this up a little longer in case you still need to mark anything down. And